Good morning, students. Now, today's lecture is lecture number 23. I am Munsi Rasidul Islam from Department of Mechanical Engineering, JS College of Engineering. Now, the paper is design of machine elements and paper code is ME503. Last day, most probably, I have completed the lecture, that is lecture number 22, and the paper topic covered is was the design of riveted joint. Now today's topic is design of helical compression spring. So obviously, that is that today's topic is actually the hardcore topic. That hardcore topic is most interesting part of the design, and that is the spring. So you have know what is spring, where it is used, what are the purpose of the using this spring, etc. But I think most of the students and most of the third year students, you have already a few idea on spring, because in strength of material chapter, strength of material subject, it has some overview was there. So for that reason, I have just told you the mainly design part. Otherwise, some theoretical part I can ignore. So, first of all, what is spring? So, spring is a one mechanical member which is used to absorb the shock absorb for the sudden load and vibration for the fluctuating load. So, actually, it is a shock absorbing element. So, shock absorbing element means it just like a shock absorbing element. Shock absorbing element means certain load and vibrating load. It can save the vehicle, it can save any material, it can save any component from the juncture or from the failure of any type of component, any type of vehicle, any type of any other things. It is not only it is used for the automobile vehicles. It spring is used in everywhere where the load is applied externally. In terms of the absorbing element, spring is used, and it is more cheaper than any component. So that is actually in the function of spring. And next, spring can made in different mode to store the energy absorption system. So energy absorption system means it can store the energy. It can store the energy means it can use just like a wristwatch, just like a toy, or any other type of children's toy, and any such physical and chemical composition blended type of material where some moving system is there. So for every field we can use the spring. Otherwise, it is not only the soft absorption purposes, it also be used for the purpose of the material where the any type of loading system is there. So that is the main function or purpose of spring. Now next, mainly two types of spring are included in your syllabus. Mainly two types. One is one is compression type spring, another is extension type spring. If you see the figure in your screen, just that is actually the compression type spring. And I today I have discussed on compression type spring, and that is also the helical compression spring. But most of the cases, uh, 10 compression type spring and extension type spring, where the extension part is there. So on that cases, to the shape of the spring is just opposite to that compression spring. If you see the helical compression spring in the screen, the two ends are the flattened system. Flattened system means there is no provision of hooking, means there is no provision of any attack, any type of hook system. Sorry, any type of hook is there. Only the two portion are in flat shape because that is compression spring. Because in compression spring, the load is applied in just this portion. So for that portion, if I put the load in two direction, so it has a tendency to compress, and if I release the load, it can go to the original shape. That is actually the compression purpose. But if I use the extension type spring, so two ends will be in hook type, because it hook type means two ends will be that hook type, and it is used for the purpose of connect the other portion. So that is the main purpose of helical compression spring, and in most of the cases in bus, truck, train, every field where the heavy automobile vehicles are used on that particular cases. Mainly bus, truck, we can use the leaf spring, but leaf spring design only theoretical part in your syllabus included. Otherwise, the derivational part or design part is actually in helical compression spring. So leaf spring, most of the cases, automobile vehicles or any other vehicles, uh, medium size vehicle or everywhere where the automobile system is there. So for that cases, we can use leaf spring. That leaf spring is quarter half leaf spring. Leaf spring are also very two and three types: halfly leaf spring, quarter leaf spring, and full leaf spring. So halfly leaf spring is used for automobile vehicles. We can see in bus, truck, etc. Now, what is helical? What is helical spring? So helical spring is a spiral wound wire with constant coil diameter and uniform pitch. Constant coil diameter and uniform pitch means the coil diameter is fixed. Wire dia, coil dia means the whole cross sectional area of the coil, that is termed as coil dia. And if I stretched this coil, so it can be a straight wire. So a thin in wire dia is called, and the thin portion dia will called as a wire dia. So for that cases, we can conclude that the coil dia always greater than the wire dia. So if I noted that the coil dia is expressed as capital D, and wire dia is expressed in small d. So wire dia by capital wire dia, sorry, coil dia by wire dia means capital D by small d, and that is denoted by the capital letter C. That C is known as the spring index. That C is known as spring index. Now, function of helical spring. Function of helical spring means that is actually helical spring where it is used. So I already expressed the spring or different types of spring. But what are the actual function of a helical compression spring? That I told you, that number one, used to store energy and subsequently release it. So obviously, if one spring one type of spring, if load is absorbed, so one type it can be released, otherwise it is not possible. That is the property, that is the relation of spring. So it can absorb energy, and when the energy is already loosened out, so it can release. Number two, to absorb shock. Obviously, the it can be used for the shock for sudden loading, and absorb shock for the fluctuating loading. Number three, to maintain a force between contacting surfaces. So, so to maintain a force between contacting surfaces, so it can be used as a contacting surface between the two contact surface when are in contact when are in engaged position. So it can be released, and it can be contact between the two surfaces. Now, next is design consideration of helical spring. So number one, the design of a new spring involved the following consideration. Number one, space into which the spring must fit and operate. Number one. Number two, values of working forces and deflection. So obviously the deflection can be considered for the design perspective. So why deflection can consider? Because the deflection can happen when the external load is applied. If you are not applied external load, it cannot be possible for the extra load applying. So next, accuracy and reliability needed. Next, uh, tolerance and permissible variation in specification. So tolerance and permissible variation. Permissible variation means the variation can depend upon the load actuating. Load actuating. So load actuating means the maximum. One spring means maximum unlimited load can absorb. It cannot be possible. Every spring has a maximum limit, and if the maximum limit is crossed out, so it can maybe failed or totally collapse. So that is actually the permissible variation. Specification also be mentioned, and obviously the tolerance limit. Next is environmental conditions such as temperature, presence of the corrosive atmosphere. It can also be considered. Environmental conditions means such as temperature, and if the more temperature or more heating position is there near the spring material, so it can be hampered, and it can be its life can be reduced. And obviously the corrosive atmosphere, so due to corrosive atmosphere and temperature, and the due to the total environmental conditions, so material life may be reduced. Next, cost and quality is needed. So cost and quality needed means cost must be under the limit. If the more price can consider, so customer cannot be achieve this. So cost also be more effective way to calculate the most of the material with high quality, and also be permittable cost limit will be there. So in these six parameter can be considered as the design of helical compression spring. If one or two process are may not be considered, so design will not be complete in 100% and perfect. Next, nomenclature of helical compression spring. So if you see the figure in right top corner, So that is actually the first of all you have to see the figure. So right hand side free length, it is denoted by LO. The free length means if all the it is actually coil based. So if I coin in top to bottom and it's traced with two sides with some tensile load, it can be a only wire, not the coiled wire. So free length will be LO. Next, mean dia, topmost portion, that is actually coil mean dia, and it is denoted by capital D, and small d wire dia. If wire dia, obviously I already explained that the wire dia small d is always less than the coil dia. So coil dia always greater than and the wire dia, and for that cases the coil must be in the circular base way, and it is actually. And next, pitch. Pitch, that is actually pitch means the one coil to the another coil, some gap is there, some distance is there, that distance is considered as a pitch. Next, as it is a as it is a helical compression spring, for that cases some angle will be there with some one coil end and one coil start. So some angle will create, that angle is called as coil angle, and that angle is denoted by alpha. Now, spring index, capital C spring index, that is actually D by D, capital D by small d, that is spring index. Now, small d or dia, it is also in millimeter, and also in millimeter or meter. Next, capital D in spring diameter, that means the coil spring diameter. Spring inside diameter di, spring inside diameter di, spring inside diameter with loaded conditions, that is DIL. Capital E is equal to Young's modulus, that is Newton per millimeter square. F is axial force, Newton. G is modulus of rigidity, Newton per millimeter square. And another important and most important term of this helical compression spring, that is actually a factor is considered for the helical compression design. That factor is known as wall factor. Wall factor. That wall factor is considered in the base of the spring index. In the base of the spring index means the spring index is C, capital C. So wall factor is equal to 4C minus 1 whole by the 4C plus 5 plus 0.615 by C. That is actually the one empirical equation. It is not the derivational equation. It is a empirical equation, and that wall factor is considered as the perfect design procedure of helical compression spring, and that is the wall factor consideration, and that is basically a standard format of considering or multiplying with the actual design. LO is actually the free length. LS solid length. Solid length means solid length can be obtained when the spring are in compressed condition. If spring in free condition, it can get the free length, and if the spring are in compressed condition, it can get the solid length. NT actually total number of coil. Total number of coil is denoted as NT. N is equal to total number of active coil. P is pitch, and it is in meter. Y is the distance between the neutral axis to the outer fiber of the wire. T is equal to shear stress, and that tau, sorry, T not, that is not T, it is actually expressed in tau. Tau is equal to shear stress is in Newton per meter square. Tau max is equal to maximum shear stress, and theta is the deflection. So another point is not mentioned here, that is actually stiffness. Stiffness, sorry for interruption.